Okay, so now we move on to scalar product. Let's consider two vectors A and B. The scalar product sometimes is called dot product, and we represent it as A dot B when we have a scalar product. And if our vectors are arranged in this manner, where we have the tips of B pointing here and our A pointing here, so that is tail to tail, and the angle between them is phi. So we can obtain their components along B axis and A axis. You remember how we have used SOHCAHTOA, that is our trigonometric identity. So for us here to get our components along our A, so if we extend this line here, we have what is on our figure B. And if you find the cos of this angle, which is cos theta, I will know that cos theta is going to be adjacent. Let's suppose that this is the unknown we are looking for. Let's call it x, divided by our hypotenuse, that is B. So therefore, we can say B cos theta equals to x, and x is this unknown that we are talking about. And at the same time, if we want to find the component along vector B, we can find it by extending this triangle like this. So we can also find the component along B by extending this diagram this way. That way, we can also use our cos of our angle. And if you look at that, we have our opposite, which is going to be A, because our angle is 90 degrees. Okay, so we can also find our adjacent, which is going to be cos theta, to be equals to our adjacent. Now, what is our adjacent? Given that our triangle is in C, our adjacent becomes the unknown, which is going to be this point we are looking for. So let's call it x, divided by our hypotenuse. And our hypotenuse this time is this, given this triangle. So we have our hypotenuse is the longest of the triangle. So when you look at this triangle, the longest point is this. So this is going to be A. So we have it as A. So we can then find the unknown part as A cos theta, which is the unknown indicated with this arrow. That's how we obtain A. The most important thing we want to take away from here is that when we have our dot product of our vector A dot B, we have it as A dot B to be equals to A cos theta, so which is the same as AB cos theta. The most important thing to take away from here is that when we find the dot product of our vector A and B, we obtain AB cos theta as we have explained earlier, which is the same thing as BA cos theta. So these are the modulus of A and B. Okay, and when we have A dot B, is the same thing as B dot A, and this is what we call commutative of vectors. So we take this formula as the dot product, which is very important that we should know. Okay, and we should as well understand that our dot product of our vector is commutative. A dot B is same as B dot A. So how do we calculate the components of our scalar product? Last time we mentioned that our unit vector can be represented as I, J, and K. And if we are to find the dot product of our unit vector, given that our dot product is A dot B cos of the angle between them, let's say theta. So in this instance, our A will mean our I and the I. So that means we have I dot I cos the angle between them. If the angle between them is 0, meaning that I is moving along I and J is moving along J and K is moving along K, meaning that the angle is 0 and we know that cos 0 is 1. Therefore, I times I is the same thing as 1 times 1, since we said in our earlier explanation that our unit vector is equals to 1. So this is represented as A dot B cos of the angle, which is 0, and that gives us 1 times 1 representing our unit vectors I and J, I, J or K, cos the angle between them gives us 1. So each time we find a dot product I dot I, J dot J or K dot K or unit vector multiplying itself is going to give us 1. So we should try to remember that. However, if we have a unit vector multiplying another unit vector, you should understand that the angle between this vector J and I is 90 degrees and angle between J and K is equally 90 degrees and angle between K and I is 90 degrees. So if one of these unit vectors are multiplying each other, the angle is 90 degrees and cos 90 is 0, and that's why we obtain 0 here, when 1 and 1 represent our unit vector multiplying one another, where cos 90 is the angle between them. So another way to see it is that when you say I dot J, this means that these unit vectors are perpendicular to one another, given that the angle is 90 degrees. So our task here now is to find, for instance, the vector A and B in terms of their components along X, Y, and Z. So how do we do that? So let's try and work it out. And we shall be using these relations that we explained earlier. Okay? So to do this, we write as follows. So we have our A dot B. We have our vector here, which is equals to this given here as dot. So we do our normal expansion, that is, we multiply this by all the components in the other bracket. So let's do it together. We have AX multiplying BX, so we have AX and BX. And the unit vector here is I dot I. We have our cap here, plus this AX also multiplying BY. So we have AX times BX. And the unit vector here is I dot J. Okay? And the next one is this one multiplying the third component of B, which is going to be AX times B subscript Z, and the unit vector is I, this I here, times K. Then we continue, we do the same for the second component of our vector A. So for our vector A, we multiply like so, which is going to be AY BX, and the unit vector is J dot I, plus the second component of B is going to be AY multiplied by BY, and we have J dot J. And also this second component is multiplying the last component of vector B, which becomes AY times BZ and the unit vectors are j dot k. Then we continue like so. We have this component multiplying the first one, which is az, multiplied by bx, and we have our component k dot I plus this term here multiplying the second, which is az times by, then we have k dot j plus this component here multiplying this, we have az bz, then our unit vector k dot k. So when we have something like this, we can now apply this relation and eliminate what needs to be eliminated. So we learned here that I multiplied by I is 1. So that means ax bx is ax bx. And we also know that ax by multiplied by unit vector I dot j is 0. So that means this becomes 0. And we also know that ax bz multiplied by unit vector I dot k is 0. So because they are perpendicular and is 90, cos 90 is 0. This also becomes 0. Then we also have ay bx multiplied by j dot I will give us 0 as shown here. And then we therefore have ay by. Then, so this is done. Likewise this. Now we also have j dot k turns to 0 as given here because j dot k has 90 degrees between them and cos 90 is 0. Don't forget that our vector is ab cos 90 and cos 90 is 0. We also have k dot I. Let's say k is a and I is b and cos 90 between them is 0. So this becomes 0. And this also becomes 0 because of k dot j. Now we are left with az bz. And this is what the meaning of a dot b means. So when you say the dot product or the scalar product of our vector ab is given as this. So we have another example here. Let's look at the example. We are asked to find the scalar product of two vectors a and b given in this figure. And our vector b is, let's say, 5 meters in magnitude and a is 4 meters in magnitude. And the angle between them is phi. And the angle b makes to the horizontal axis is 130 and the one made by a is 53. So our question is find the magnitude of the vectors. So what do? Let's take this to our whiteboard marker. So we have two methods to work this out. So let's start the first method. The first method, we know that AB dot cos the angle between them is A dot B. So therefore, if I know my A, the magnitude of A from the question is 4 and that of B is 5. If I find 4 multiplied by 5 cos of the angle between them, so what is the cos of the angle between them? What is phi? If you look at this carefully, we can calculate phi to be the difference between 130 minus 53. And that gives us what? Let's press our calculator. So we have 130 minus 53. So what do we have? We have 77. So the angle between them is 77 degrees. So we can find cos of 77 degrees equals to A dot B. Or we can say A dot B is equals to 4 times 5 is 20 and 20 times cos 77. Let's press our calculator one more time. Let's find cos 77 and that gives us 0.2250. And if we multiply that by 20, we have 4.5. So our answer is 4.5. So I said earlier that we can try another method to work this out. And what is the other method? In the last time we said that A dot B is the same thing as AX BY plus AY BY plus AZ BZ. So that means if I calculate my AX and my BX and I calculate my AY and my BY and at the same time I calculate my AZ and my BZ, I can obtain this and substitute. So what is my AX? My AX is defined as magnitude of my A plus the angle, and my AY is going to be magnitude of my A plus the angle. And we can use the same for my BX, which is going to be B cos theta, and BY B cos theta, and also my AZ is equals to AZ cos theta or A cos theta, and my BZ is going to be B cos theta, like so on. And for my AX, what is my A? My A is given as 4 and cos of the angle is 53. So I have 53. And for my AY is going to be 4 cos 53. But if it is on a y-axis, A on the y-axis, my AY is going to be sine, not cos, please. Because it's vertical, so I have A sine theta and this B sine theta. So for this, I have 4 sine. My sine angle here is 53. And also for my B given in the question is 5. And the angle cos theta here is 130, which is the angle it makes with the x-axis. So I have 130. And this is also 5, but this time around is sine of the angle because it's along y-axis. So sine 53. I do not have any component along z-axis, and neither along my B doesn't have anything along z-axis. So no component along z-axis. So it's 0. So if I substitute here, I have my A dot B to be my AX and BY. So but initially, what is 4 cos 53? 4 cos 53 will give me 2.407. And for my BX, I'm going to get minus 3.214. And what is 4 times sine 53? 4 times sine 63 will give me 3.195. You can confirm that by pressing the calculator. So we have 4 multiply by, you can open the bracket for our precision, and 53, and the sine angle of 53. We close the bracket and everything should give us 3.195. So we have 3.195, so we are close, we are correct. And what is 5 sine 53? We don't have 5 sine 53 because the angle that B makes with the x-axis is 130. So we have 130, just the same way we calculated for BX. 5 sine 130. So we have our 5 times 130. Then we find our angle sine of 30. Then our final answer is 3.83. So that is 3.83. So for that reason, we can then substitute that into this our expression. Our AX is 2.407. So we can save that. 2.407 multiply by our BY. So this is BX. Sorry. This is BX. And our BX is minus 3.214. So everything in brackets plus what is our AY is 3.195 multiplied by our corresponding BY, which is 3.83, plus our Z components, which are 0. So we have 0 multiplied by 0 because our question has no component along Z direction. So therefore, our final answer is just like this, and if we work this out, we have A dot B is the same thing as 4.5. So we use different methods to arrive at the same answer.